Hi, welcome all. In this video, we are going to learn about the basics of NodeMCU. This session is intended for beginners who want to start doing projects in IoT using NodeMCU. So, what is NodeMCU? The full form of NodeMCU is Node Microcontroller Unit. It is actually a development kit used to prototype or build IoT-based projects. NodeMCU development kit uses ESP8266 Wi-Fi SoC from the company known as Expressive Systems. Here SoC means System on a Chip, and the company known as Expressive Systems is the one who first manufactured this SoC known as ESP8266. Actually, ESP8266 is a family of different modules. This is not a single chip. Actually, it is the name of a family, ESP8266. And ESP8266 family contains a number of modules. And some of the important modules are ESP01. This is the first module produced under this family ESP8266. And other important modules are ESP05, ESP12, ESP12E, etc. Lot of other modules are also there in this family. I have just mentioned some of the important modules here in this list. And the NodeMCU kit, that is the development kit. Actually, the NodeMCU kit has two versions, that is version 0.9 and version 1.0. 0.9 is a old version, that is the first generation version, and the latest current version we are all using for doing projects is version 1.0, that is NodeMCU version 1.0. And this version uses the ESP12E module as its microcontroller unit. So generally, when we do projects using the latest NodeMCU kit, it contains the module ESP12E. So we have seen that NodeMCU is a development kit. But why we use a development kit? Why can't we use directly the ESP8266 SoC for doing projects? We can see that the ESP8266, as we have mentioned earlier, is a system on a chip which contains CPU, RAM, Wi-Fi connectivity, etc. inside the single chip itself. But the problem is SoC, that is this ESP8266 SoC alone is very difficult to use as such for prototyping projects, because we need to set appropriate analog voltage to its pins, have to solder wires, have to connect switches for reset, flash, etc. Also need external flash memory to store programs. That means we need an extra chip to connect to this SoC for storing programs, data, etc. And also USB communication for making the communication possible with our laptop or desktop. We need to connect other modules also, serial communication ICs, chips, etc. also with this ESP8266. So in brief, even though the ESP8266 is a SoC which contains CPU, RAM, Wi-Fi connectivity, etc., in order to use it in a project, we need to connect a number of extra modules also. That is the flash memory, and also we have to provide the appropriate analog voltage. That is actually the working voltage of this ESP8266 is 3.3 volt. So we have to externally supply this correct regulated working voltage to its appropriate pins. For that, again, we have to solder wires to its pins, and lot of such things we have to do. We have to connect switches for reset, for flashing, etc., etc. So actually doing all these extra connections and all these things to this SoC is a very difficult task for the most of the people for doing some projects using this ESP8266. So to solve the above mentioned problems and to make things easy, we use a development kit, that is the one known as NodeMCU. So in this figure you will get a very clear idea about what is NodeMCU. So this is the ESP8266 SoC itself. This is the bare IC itself, ESP8266. And this IC plus all the extra circuits we have mentioned in the previous slide. That is the circuit for providing the correct voltage, the circuit for enabling the serial communication with our PC or laptop, the circuit for storing external data or our program code itself, that is flash memory for connecting the flash memory, all those circuits, all those extra circuits. So for using the ESP8266 in a project, we need all these extra additional circuits to be connected with this ESP8266. So ESP8266 connected with all these additional circuits is the NodeMCU development kit. You will get a very clear idea now with this animation, that is ESP8266 plus all these extra components built in a single hardware package is the NodeMCU. Now you must get a clear idea, that is the ESP8266 plus all the extra components, that is the USB port, the switches for reset and flashing, the extra IC for serial communication, the IC for voltage regulation, etc, etc, the Wi-Fi antenna, etc, etc. So all these external components plus this ESP8266, and all these things comes in a single hardware package, that is the NodeMCU. And we can easily use this NodeMCU for doing all our IoT projects without any extra components. Now we can see in brief about the NodeMCU project. Actually, the NodeMCU is a project started aiming to simplify the ESP8266 development, and it has two key components. Actually, an open source ESP8266 firmware that is built on the top of the chip manufacturer's proprietary SDK. The firmware provides a simple programming environment based on the embedded Lua, which is a very simple and fast scripting language with an established developer community. And second component is a development kit that incorporates the ESP8266 chip on a standard circuit board. That is, this ESP8266 in a standard circuit board. The board has built-in USB port. This is the USB port that is already wired up with the chip. This port is already connected with this ESP8266 chip. A hardware reset button, that is this button, hardware reset button, a Wi-Fi antenna, and LED lights, and standard sized general purpose input output pins. What is the use of general purpose input output pins? By using these general purpose input output pins, we control external peripherals. For example, if we want to control a relay or we need to light an LED, we use these type of general purpose input output pins, and that can plug into a breadboard. So the NodeMCU project has two key components, that is the ESP8266 firmware, that is the open source firmware that is programmed inside the ESP8266 module itself, plus the development board, this hardware board. So actually the NodeMCU is a combination of both an open source firmware, that is a software, and the hardware. This both comprises the NodeMCU project, that is the NodeMCU development kit. Now we can see some important specifications about our NodeMCU development kit. First one is power section. How we can power our NodeMCU module? There are number of options. The first one is through the micro USB port. This is the very easiest and convenient method. Through this micro USB port, we can connect the NodeMCU to our laptop or desktop, and the laptop or desktop can provide the appropriate voltage and current for the working of NodeMCU through the connection via this micro USB port. And the second option is, you can see the 3.3 volt pins here, that is the in red color pins, that is 3.3 volt. You can see 3 pins here. We can directly give 3.3 volt regulated 3.3 voltage to the NodeMCU for its working also. And of course there is a ground pin there, that is 4 ground pins are provided, that also we have to connect. And another pin is V-in pin. In this V-in pin we can give 5 volt, regulated 5 volt as input voltage also. So these are the methods for powering the NodeMCU. Next is about the control pins. There are 3 control pins in our NodeMCU unit, that is EN, enable pin, RST, that is the reset pin, and the wake pin. So enable pin is active high. So for the normal working of the NodeMCU module, this pin must be actively high, enabled high. This pin must be active high for the normal working of the NodeMCU module. Next is the reset pin. Actually this is the reset pin, and a push button is already connected in the hardware itself, this kit itself, for resetting the module. If you want to reset the module, we can push this switch. That will make the NodeMCU to start the program from first itself. That is, it will reset like when we push the reset button of our laptop or our desktop, similar function. Next is the wake up pin. There is a mode known as deep sleep mode in NodeMCU for saving the power consumption. If the NodeMCU mode is in deep sleep mode, NodeMCU module is in deep sleep mode, and if we want to bring it back to the normal working mode, we use this pin, that is the wake pin. That is, consider that like a human being, the NodeMCU module is sleeping and we want to wake it up. For that purpose we use the wake pin. So these 3 are the control pins of the NodeMCU module. Next is the analog pin. Analog pin is the A0 pin, you can see here. From this side, the first pin is the analog pin. The analog pin A0 is used to either to read the voltage at the ADC pin, that is it has a built-in ADC. So in order to read the input voltage at the ADC pin, or to read the module's supply voltage VCC itself. So for 2 purposes we can use the analog pin A0. That is, first one is to read the voltage at the ADC pin, or to read the module supply voltage at the VCC pin. So these are the 2 main purpose of this analog pin A0. Next is the GPIO pins. Actually the NodeMCU module consists of 16 GPIO pins, out of which 10 are for digital input output purposes. We can see more details about this GPIO pins when we do projects in our coming sections. So SPI pins. There are 4 SPI pins in our NodeMCU module, that is S1, CMD, SD0, CLK. Regarding this also we will know more when we do projects using these pins in our upcoming sessions. Next is UART pins. UART pins is used for serial communication. In our NodeMCU module, there are 2 sets of UART modules, that is TXD0, RxD0, and the second set is TXD2 and RxD2. Now we can see the different sections in our NodeMCU kit. that is the physical parts. We can see what are the different physical parts in our hardware kit. As we have mentioned earlier, there are two physical buttons provided in the NodeMCU board. First one is for reset, that is for resetting the entire NodeMCU module and to start its working from the initial stage. Same function like the reset button in our laptop or in our desktop. Second is the flash button. This is for the programming purposes. When we upload the code to the programming code to our NodeMCU module, we use this flash button. Next is the micro USB port. The micro USB port is used to power up the NodeMCU module from the laptop or desktop, and also for data communication for programming purposes. So for that we use the micro USB port. Using a micro USB cable, we have to connect our NodeMCU module to our laptop or desktop while programming. Next is the USB to Ttl converter. That is from our laptop we connect to the NodeMCU to a USB micro USB port, and from the USB port we have to convert the data signals to the Ttl format so that it will get recognized by the microcontroller in the ESP8266 module. For that purpose we use a USB to Ttl converter. That is the IC here. You can see a small IC situated here. So that is the USB to Ttl converter section. And there is a onboard LED. There is an onboard LED in the NodeMCU module. We can use this LED for testing purposes. We can write some sample programs like for blinking programs for testing whether the NodeMCU module is working properly or not. For all that testing purposes etc., we can use this onboard LED. The default digital pin of this onboard LED can sometimes vary, depends upon the manufacturer of the NodeMCU development board we are using. Next is the 3.3 volt voltage regulator. As I have mentioned earlier, actually the working voltage of NodeMCU is 3.3 volt. But when we power up the NodeMCU module using a laptop or desktop or from an external 5 volt voltage source, the NodeMCU input voltage getting is 5 volt, and we have to convert that voltage and regulates that to 3.3 volt. For that purpose there is an IC situated here for controlling and regulating the voltage to 3.3 volt, and after that it will feed the regulated voltage to the ESP8266 module situated in the back side of that voltage regulator. And this is the main IC SoC, that is the ESP12E module of the ESP8266 family. It is used in the NodeMCU version 1 of development kits. And the last one is the Wi-Fi antenna. As we have mentioned earlier that the NodeMCU contains an Wi-Fi internet connectivity option, and for that purpose there is an antenna which is of 2.4 GHz connectivity bandwidth. So these are the main sections in the NodeMCU development kit board. So the main features are: the NodeMCU ESP8266 development board comes with the ESP12E module, that is this one, ESP12E module containing ESP8266 chip having 10 silica extensa. These are the name of the company of the model. You don't have to worry about these lengthy complex names. 32-bit LX10 RISC microprocessor. Actually, if we take the microprocessor classification, you will know that there are two classifications basically. One is the CISC and the another one is RISC microprocessor. So our NodeMCU ESP8266 family comes under this RISC microprocessor category. You don't have to worry about these long and complex names. And this microprocessor supports RTOS, that is real-time operating systems, and it operates at 80 MHz to 160 MHz adjustable clock frequency. So regarding a microcontroller, this working frequency is very high when compared to other similar category microcontrollers. 80 MHz to 160 MHz is very excellent working frequency. And regarding its storage, NodeMCU has 120 kilobytes of RAM and 4 megabytes of flash memory to store data and programs. So as a microcontroller, this storing capacity is very large. With 4 MB we can store a huge amount of data and a program code in this NodeMCU microcontroller. Its high processing power with built-in Wi-Fi and Bluetooth. Some of the versions contains Wi-Fi and also a Bluetooth. And deep sleep operating features makes it ideal for IoT projects. So these all are the main features of our NodeMCU module. And the last one is NodeMCU can be powered using micro USB jack. We have mentioned that already. And V-in pin, external supply pin. That also we have mentioned in our previous slide. It also supports UART for serial communication, and other communication protocols it supports are SPI and 12C interface. You don't have to worry about all these SPI and 12C interface things, because in the upcoming sessions when we do projects with such protocols and interfaces, we will learn more about those things. Now we can see the different models of NodeMCU. Actually, the NodeMCU is available in various package styles. Common to all the designs is the base ESP8266 core. So no matter what model we purchase, the basic common thing it contains will be the core ESP8266 module. Without that, there will be no NodeMCU. Designs based on the architecture have maintained the standard 30-pin layout. So again, no matter what module we buy and what model we buy, all those contains a 30 pins layout. All these models contains a 30 pins. So some designs use more common narrow footprint while others use a wide footprint. So means the width between the two rows of pins in some models contains 0.9 inch gap, and some other models contains 1.1 inch gap. Those are physically larger than the one with 0.9 inch gap. So the most common models of NodeMCU are produced by one or two companies. The one is Amica and the second one is Lolin, which has a wider pin spacing. So Amica is considered as more genuine and more quality NodeMCU modules, and it has a small form factor when compared with the other third-party modules and Lolin NodeMCU modules. These are the names of the companies actually, Lolin, Amica, etc. So Amica is considered more quality NodeMCU module, and it has a small form factor, and the gap between the two sets of pins is only 0.9 inch. So it will consume only very less space in our breadboard. On the other hand, the Lolin module or lot of other third-party companies are also producing these NodeMCU modules now. I have not mentioned all those names here. The Lolin module, on the other hand, has a big form factor when compared to Amica module, and it will consume large breadboard space, and the width between the two set of rows is 1.1 inch. So that is the basic difference between these two models. So the main difference is, other than the difference in the physical dimensions, the main difference between the official Amica NodeMCU and Lolin's NodeMCU is the serial converter chipset used. So we have mentioned earlier that, we can go to that slide. So we have mentioned earlier that here that as we are connecting the NodeMCU to our laptop using a micro USB port, we need to convert those USB signals to the TTL signals so that it can communicate with the microcontroller inside this ESP8266 module. For that purpose, we have to use a USB to TTL converter chip that is shown in this figure. So here what mentioned is the two types of modules, that is the one produced by the Amica and the one produced by Lolin and other companies. The main difference is in the serial converter chip used. In the official Amica NodeMCU module, here the chip that is shown as enlarged. Here in the official Amica NodeMCU module, the serial converter chip used is CP2102 chipset. It is considered to be a more better chipset, and in Windows 10 it has native support also. So we don't have to install any extra driver software for its working in Windows 10 or its other Windows operating systems. But in Lolin NodeMCU or the NodeMCU produced by other third-party companies, the serial converter chipset usually used is CH3403 chipset. Actually, it is a China-based chipset, and it is normally used in lower-priced cheap modules. It doesn't have much quality like that of this CP2102 chipset, and also it requires a separate installation. We have to download extra separate driver from this site, CH340G's site, and we have to install it separately. Only then our Windows or our other operating systems will recognize this chipset, and only after that our laptop will be able to communicate with this NodeMCU module if this module is using this CH430G chipset. So depending on the operating system you are using with the NodeMCU, the appropriate driver must be installed first. Generally, Windows 10 immediately recognizes the CP2102 chipset, while the CH340G may require separate installation. I will provide the correct link for the CH430G and CP2102's official site, so that if you encounter any problem while installing these chipsets, especially problems encountered when you purchase a module with this CH series chipsets, you can directly download the driver from their official site. I will provide all these useful links in the description section of this video. So now we can see how we can program a NodeMCU module, how we can connect the NodeMCU module to a laptop, and how we can program it. So for programming the NodeMCU, mainly we use two methods. The first one is using the NodeMCU with Explorer IDE and using the Lua scripting language for programming. And the second method is NodeMCU with Arduino IDE and using the C or C++ programming language. The second method is the easiest one, especially for beginners. Also, there is a large community base for Arduino IDE, and so a large number of libraries are readily available for making the programming task easier. So in this tutorial series, we will be using Arduino IDE method for doing projects with NodeMCU. So we can see how to set up all these things so that we can program the NodeMCU with the Arduino IDE. It will hardly take 5 or 10 minutes for all these things. So the basic requirements are, we have to install the Arduino IDE. Again, I will give the link of the Arduino site in the description section of this video so that you can easily go there and download the Arduino software and install that in your laptop. And the next requirement is a USB cable for connecting the NodeMCU board to the laptop or your desktop. And then the NodeMCU development board itself. So after connecting the NodeMCU to your laptops, make sure that you have installed the correct driver for the serial converter. Chipset depends upon the make of the NodeMCU you have purchased. These things we have already discussed in our previous slide, that is this slide. That is, if you purchase an original Amica NodeMCU module, so Possibly your Windows 10 itself supports the chipset and you don't have to install any extra drivers. But if you purchase a NodeMCU with a CH3403 chipset, maybe you have to install a separate driver downloading from their website. So after installing the driver and after installing the Arduino IDE, we have to make some basic setups so that Arduino IDE is used for doing projects with the Arduino development kit, but here we are using the Arduino IDE for programming the NodeMCU development kit. So for Arduino IDE to detect the NodeMCU kit, we have to first make some basic setups to our Arduino IDE. So I will tell you the steps for doing that. The first step is, after installing the Arduino IDE, from the file menu, click the preferences and you will see a screen like this. From there you will see a section like Additional Boards Manager. First there will be a blank section there, and we have to copy this URL. I will give the URL also in the description section of this video. You have to copy this URL and paste here and click OK. So you have to click on the file menu, then you have to open the preferences and then have to copy this URL and have to paste the Additional Boards Manager section, and after that you have to press OK. Next, what you have to do is, after the previous section, from the Tools menu, you have to take the board and then you have to go to the Boards Manager section, and you have to search by typing NodeMCU like that. Here you have to give NodeMCU and you have to search, and you will get a section like this, that is ESP8266 by ESP8266 community. You will see a section like this when you search by giving NodeMCU and type enter, and you have to install it. Once you have installed, maybe if you want you can remove it later. First time you have to install it, and after installing you have to close the Arduino IDE and you have to start it again. Only then it will become effective. And if everything is installed properly, then you should be able to see the newly installed boards under Tools and Tools menu and the Board menu. Board menu you will see the NodeMCU 1.0 and 0.9 versions. Make sure that you will select only NodeMCU 1.0 version. That is the latest version we are using for doing all our projects. Sometimes there will be a small difference in the menu you are seeing when you install in your laptop. Depends upon the Windows version or the Macintosh version, and also depends upon the version you are installing. Sometimes it will be under Menu, Tools, Board, and then ESP8266 boards, and then NodeMCU 1.0 you have to select. When you see it, you will understand it clearly. Now we have to test whether our NodeMCU have installed correctly and we have correctly set up our Arduino IDE. For that we have to do a example blinking program. For that, from the menu, open the example blink program from the example for NodeMCU 1.0 section inside the example menu. So when you open the Arduino IDE and click on the file menu, from there you will be able to see a examples submenu. Under that you will be able to see an ESP8266 section, and from there a lot of example programs have given. From that list you have to select the blink program. So the LED blinking program will look something like this. We will learn more about programs later in our upcoming sections. So this example program will look something like this. and after that you have to select the correct board and correct port number and then have to upload the program. That's it. Now the built-in LED in this program we have mentioned to blink the built-in LED. So in this case we are not connecting any external LEDs for testing, but on the other hand we are just using the built-in LED for the blinking purpose for testing the board. And that LED should start blinking after we have uploaded this sample LED blinking program. It will look something like this. Once the code is uploaded, the LED will start blinking, and you need to tap the reset button to get the ESP8266 to begin running the sketch. So once the code uploading is complete, you have to press the reset button on the board, that is a development kit. We have already seen there are two push buttons and one is the reset button. So after uploading the code we have to push the reset button to start the program. Only then LED will start to blink. So if due to any problems even after uploading the code, if the LED is not blinking, we have to just test it by changing a small making a small change in the code. That is we have to change the LED built-in section, that name to the D4 to D4, because D4 is the name of the built-in LED ports, LED's port number. In the first program you can see that we have given us LED built-in. LED built-in is mapped to the built-in D4 port, or if some other port, depends upon your model of the NodeMCU. And if that is not working, we just have to change this to this LED built into the name D4 for testing. Then it will surely work if all our things are set up correctly. So I hope that you all now got a basic idea about the NodeMCU and how we can set it up for doing projects in IoT. So if you have any doubts, you can surely contact me in the WhatsApp numbers I have provided. And also if you need any help for programming or projects, also you can contact me. So next we will start doing some projects using this NodeMCU in our upcoming sections. So if you like this video, please like it and share it among your friends and subscribe the channel. Thank you friends.